Okie doke. Question for the class. What is AI observability? My name's Tim Osborne. I write about data and AI here at Monte Carlo, and today that is exactly what I want to talk about. I want to dive deep into the AI observability soup. I want to talk about what it is, why you need it, how it differs from other forms of observability, and at the end of the day, how do you choose an AI observability solution that will actually make your AI more reliable, which I believe is the goal of AI observability. So if that sounds at all interesting to you, or you're just really bored, come on this journey with me and let's dive in. So first question, what is AI observability? Ooh, that's a great question. Oh, thank you, other Tim. In the simplest terms, AI observability is the ability to monitor AI applications from source all the way to the output. Now, you might also know AI observability by one of its many other names: agent observability, LLM observability, data and AI observability. While some of those are admittedly more accurate than others, they all get to one basic idea: what performs perfectly in testing will never perform perfectly in production, and we need a solution to mitigate that risk. The problem with AI is that it doesn't fail loudly like some traditional software application. It fails silently. And by the time you actually figure out something is wrong, that issue could have cascaded into all kinds of model failures. At a philosophical level, all observability is functionally the same thing. It aims to do two things: minimize downtime and maximize value. So you might be very unsurprised to know that AI observability takes that same philosophy and just slaps it right on top of an AI application, but with a non-deterministic twist. You see, unlike traditional products like software applications or dashboards or even ML models, when it comes to AI, A plus B does not always equal C. So that is to say that what you put into an AI model is not necessarily what's going to come back out of that model. In reality, you can ask a model the same question 5 times and get 5 different answers, which means that defining a successful response and monitoring for it, or monitoring for uptime in this scenario, is more difficult than it seems. Let's elaborate on this a little more. So when we're talking about success, here's some questions to ask. Is an output only unsuccessful if it technically fails to run? Or is it maybe unsuccessful because the response is not quite accurate? Or it's close, but it's missing some things? Or maybe the response is accurate, the application ran, but the tone was off. How do we monitor for those things? How do we define good in those circumstances? Enter AI observability. So what is AI observability monitoring specifically? So there's essentially 4 things: response accuracy. How close is it to what it's supposed to be? Explainability. Do we understand how this response came to be? Model performance, and cost. So what are some of the critical features that enable us to do that? Well, there are essentially 2 features that are integral to any AI observability solution. Number 1, evaluations. So evaluations, sometimes called LLM as judge evaluations, are essentially using AI to monitor AI. So where this is really, really valuable is for things like sentiment analysis. So if we want to look at dimensions like helpfulness or validity or accuracy or relevance, and evaluation is going to be really, really good for doing that. So number 2, after evaluations, is tracing. So you can think of tracing in the same way you might think of lineage for a data product. So tracing is going to be good for a couple things. Number 1, explainability. So understanding where that response actually came from. If it's accurate, why is it accurate? If it's inaccurate, why is it inaccurate? What are the pieces that came together to create that response? But number 2, it's also going to be really helpful for understanding how that pipeline is actually performing. If there is any kind of performance degradation, or if there's a bottleneck, or if there's something that needs special attention, how do we make sure that this model is performing as efficiently as possible to deliver the outputs that we need it to deliver? So now the most important question we could possibly ask in this whole video: does AI observability alone actually make AI more reliable? No, not really. The problem with most AI observability solutions is that they only look at really the last mile of the output, what's actually being delivered to the end user. The problem is there's a whole lot more track before that. So if we take another illustration, the iceberg, you see here at the top, I'm assuming that I've put something here. You see, you've got this ice. We don't want to hit that. We want to stay away from that ice. That's bad. The problem is, if you're familiar with icebergs, there's a whole lot more of the ice underneath the surface, and we don't want to hit any of that ice either. Just ask the Titanic. And the real problem is that what often masquerades as a model issue is actually something like a data issue in disguise. Some of the most common problems are things like poor source data quality, drift in the embedding space over time, confused or incomplete context, output sensitivity, prompt changes. There's so many things that can go wrong within an AI pipeline that have nothing to do with the model output. So if we actually want to make AI reliable, we can't just look at the model alone. We have to look at the entire system in its totality. Now, if you're in a pilot stage and you're just testing things out, an AI observability solution by itself might be fine. You might be totally fine. The challenge is when you deploy to production. Whatever flaws exist, whether they're in the model or somewhere else upstream, they're going to be exacerbated when you have real users and real user data and production scale. So when you deploy to production, you need a solution that's designed for production. The challenge that AI has that is unique to every other kind of software and data product that came before it is that it doesn't exist by itself. Data and AI are interdependent. AI doesn't exist just as AI. It is informed by your own first-party data. You can't have AI without the data and the architecture that is supporting it. So when it comes to how we monitor those things, we also cannot divorce them from one another. So what does that look like? What is a real comprehensive solution to AI observability? Like we said, it can't just look at the model, it has to look beyond the model. So in order for our AI to truly be reliable, we need to look at not one, but four things: the data, the system, the code, and the model. Observability implies that you are observing an entire system. Like data observability, it observed the entire data system. Software observability observed the entire software system. AI observability, in most cases, only looks at the tail end, the last mile, the tip of the iceberg. So you need to be able to observe all of it in totality. And finally, I think maybe the most important part is the ability to actually resolve incidents when you find them. In the same way that testing and monitoring in traditional data quality way back in the heyday didn't actually solve the problem of data quality, most solutions that are designed to make AI more reliable, with the air quotes, don't actually give you the ability to do anything with the problem that they've detected. The ability to have good, rich insights from all of the tracing and the evaluations and your data lineage and your monitors and your profiles all together and all activated for you to resolve an incident is what makes any observability solution truly transformative and actually make the thing that you are trying to observe reliable at scale. In summary, we've talked about what AI observability is, we've talked about what it's not, we've talked about what you need to actually make your AI reliable. In our next video, I want to take a deeper look at AI observability tools, what's out there, what makes them performant, and how you might go about choosing one of those solutions. If you like this video, go ahead and give it a like, maybe subscribe. If you didn't like it, I don't know. Don't do anything. If you want to read more about AI observability or AI reliability or AI-ready data or all of the good, juicy little AI topics that are coming up day after day, check out the links in the footer for more insights, and we will see you back here very soon. I don't usually hold a microphone like this, but it's nice. It's nice.